All right. So today we are going to be connecting the dots. We're going to be learning about views in Django, just what they are. And then we're going to use Django REST framework to make API class-based views and a pattern called model view controller. And we'll talk about what that is. And we'll see how to connect the URL patterns that we were introduced to yesterday from not just here in a project, but connect the URL patterns here to more URL patterns in our apps that then, in fact, will connect to views, which talk to our serializers and our models. So we're going to really put all the pieces together today. Then we are also going to dive a bit deeper into that and see how we can write tests for these API views. Do you folks have any questions about today's agenda?
When you say views, these are different than the views from the URLs.py, or are they just different versions?
Yeah, great question. Great question. So they are more advanced versions of what we did yesterday with these view functions, like this area triangle here and this area square function here. We can call these views. I would say it's a view function because you can use a class or a function to make a view. What we are going to do is this code is going to end up living inside an app. Say we had, instead of area triangle, maybe it was like def get Pokemon, or how about let's make it like all Pokemon, get all Pokemon.
I have a quick question.
Yeah.
For line 43, I guess you always need to have a path to essentially the home or the index. Because I just noticed if you delimit if you take out line 43, like none of the rest works. If you try to, pull any of the rest up. So it's like it's
Uh,
bare minimum you need to have like a path that goes to like I guess the bare
not
minimum home page or index page.
not sure about that. We'll play around with that in just a minute because I'm actually going to spin up the server and we're gonna fiddle around with this. Good question. I will come back to it. To answer your question, Tim, what we're doing today is we're going to make a view function to get all of our Pokemon, but to help keep our code organized, I don't want that here. I want it inside this views py directory in my Pokemon app, and we'll see how to connect the URLs py to this because there's going to be an extra step. It's not just an import statement, but then this will get more complicated and will actually become a class. Does that help answer your question?
Sure does. Thank you.
Yeah, totally. Great question. And let's actually spin up the server and play around with some stuff. And then Jason, we can come back to your question as well, and we can do a little warming up. So I've already installed and created a virtual environment. I've installed my project dependencies. Um, I'm going to go ahead and I'm going to run my server. Now, my server works. I can go here in the browser. And if I just only had that spelled right, we'd see Hello Zulu. And we're going to open up my favorite thing in the world, the network tab. And I'm going to refresh the page. And I'm going to clear the console here. And let's watch what happens. Um, there's a lot of HTML and CSS being fetched here that I really don't want. But if we scroll all the way up here, let's see here. Yep, no, this is the one we want. If we look at this very first HTTP request, before it starts grabbing all these things that we're not using with JavaScript and that Django adds for debugging, we see the verb or HTTP method is get. The URL is our IP address and port. And in fact, we see that get request here in the running Django server. We see this little number here, 200, that's saying Django sent back in the HTTP response a status code of 200, which means, okay, success. We have some very verbose sort of debugging information here from Django. We can, in fact, see tons of information about our HTTP request, the type of content, text, plain text, which in fact, if we look in, let's see, the request headers, we can see here all of these HTTP request headers have all this sort of information. And then it looks like this might be the HTTP response coming back, content type text plain, blah, 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 blah. We can see that here in the response headers, and this is all text under the hood, right? If I look at this with the raw view, you can actually send HTTP requests over the command line. It's a text format. This is what it looks like. And let's make our request headers raw as well. So you can see there's all this metadata that the browser adds in for us, like user agent, the name of the browser, what operating system my browser is on. And this is how advertisers kind of track you across the internet. And we see here the HTTP response that's coming from our view function that's saying hello. And the print statement here that is indeed printing those request headers. So I've made an HTTP request. It's a GET request. It's to this URL, and the server sent back a response. So far, so good, right? There is, and I just want to pause and see if folks have any questions or things you're curious about.
What are the headers again? Like, what does it contain?
Yeah, headers contain, right now, when I send a request, the headers contain metadata. What kind of file encoding can the browser accept a response in? What language is this browser, the agent in? Some rules about caching that we're not going to worry about. Cookies that we'll learn about later. Later, there will actually be an authorization header in here for authentication. What data formats this browser can handle in a response. It can receive text or HTML, a bunch of other stuff, and somewhere in there should be JSON. And then a bunch of metadata that we're not going to worry about. And then in the response, we see the first thing that's sent back is the server. HTTP requests are all about call and response. The server says, the thing you requested, I successfully got. What did I request? Since the path in my URL, in my HTTP request, was just to our base route path, our URL routing says, okay, I call this function home. We print out stuff, whatever. What do I need to return? An HTTP response. So Django along the way does some work for us and says, hey, browser, I got you what you wanted. This was a success. So we have our protocol, because there's actually protocols other than the hypertext transfer protocol, HTTP. Hypertext is a fancy word for HTML and links. The response code 200, and this is just sort of a friendly saying what the 200 is. Our response has the date. We see here some information about the server, WSGI server, the version of Python being used, the type of the content being sent back. So the browser knows, is this text? Is this HTML? Is this, a zipped up compressed file? Is it an image file? The character encoding for our text file, some sort of metadata thing I'd have to look up, how long the content is, right? Which could be relevant for the browser to figure out what to do with it. Another metadata thing we're not going to worry about, and more metadata stuff we're not going to worry about right now. You can,
Um, I'm sorry. The meta, like the metadata in there, is that different from like the meta that we have inside of our serializers?
great question. Yes, it is. This stuff is added by Django, and it's more about the HTTP protocol. It doesn't have anything to do with our data model. Yeah, great question. That's what the HTTP response class does, the work of bundling up all that stuff, right? We can actually create custom request and response headers if we want. We would just have to tell the server what to do. Um, and so all this is working great. There was one thing I noticed when I ran the server. Anyone see something that catches your eye here that could be a problem?
Migrations.
Yeah, exactly. Let's do some migrations, right? Because we added more code in the lesson yesterday, and I wasn't there yesterday, and I have the code, but I haven't applied the migration to the database. So I'm going to run make migrations just to double check there's nothing, no code we forgot to create a migration for. And now I'm going to apply my migrations. And I will open up pSQL and I will connect to the Pokédex DB and I'll look at all the tables. And just to kind of help myself get familiarized, let's look at the Pokemon moves we made yesterday and see what's in there. And nothing's in there. And in fact, if I look here, I don't have any fixtures. So we might do that in just a moment because I think that will make the rest of this lesson go more smoothly. And I've got select star from Pokemon app. Pokemon. And we've got the Pokemon back from 2 days ago when I taught. So in a minute, I think what we'll do is we'll make some fixtures, and I could use a little help with that. But before we do that, let's run our server and go back to, I think, the question that you had earlier, Jason. Actually, what I also want to do is I want to open up Django admin just as a sanity check to make sure that everything is working. So I'm going to put in my username. I'm going to type my password. Uh-oh. I seem to have a bad password here. So I think the command is, and let's give ourselves a little more real estate. Anyone remember the command to make a Django admin user?
Create super user, but I don't know how to create a regular user.
Yeah, I just want a super user. Was it create super user?
Yeah.
We'll do Adam C. We'll do Adam at codeplatoon.org. And we'll make the password and make it. And now let's try. Now, I forgot to restart my server, so I'm going to start that up again. And in fact, you may want to like have even a third terminal open so that I think it depends on your personal workflow, but so you don't have to constantly stop and restart your server. And now I'm logged in and I can see all of our stuff. And we can add things to the database. Now let's briefly play around with URLs PY. Let's go back to your question, Jason. Let's comment out this home path. Let's see what happens. This fails, which I would expect, because this route no longer exists. And we get a page not found error message. If I go over here to Django admin's working fine. And in fact, we can see the HTTP requests here between the browser and the server. These was get admin / move when I moved over here. If I click on home, we'll see get admin, just plain old /. So Jason, to answer your question, I think what you encountered yesterday, there may have been another issue going on, but we can see that I can comment out a path just fine and Django doesn't break. But it does tell me the page is not found, right? And if I look in the network tab, and again, we just have to ignore all this other stuff. There is some way to filter it out. I can't remember it at the moment. Let's see if they hide data URLs. No, I'm not going to worry about this. If we look at this HTTP request that our browser sent, we see same request, but the server response is a 404 status code, which is an error code. It says the server could not find this resource. And then we have all this other stuff. All this stuff loaded in here, the JavaScript and the CSS and all that. Oh, and then if we look in the response from Django, we see it actually sent us a bunch of HTML because Django's in debug mode. And this is the actual HTML with the stylings and everything that we're seeing right now. You can see here's the page not found header. So Django has generated some HTML, which in the days before React.js which was how everything worked, and sent it back to us because Django's in debug mode and gives us nice error messages. And now if I uncomment that route, note that Django kind of restarted its server, I think. And if I refresh here, now we're cooking, right? And if I change this path, if I wanted to change it to like my home, then this would fail. But if I change the URL, what did I do wrong? I might need to restart the server.
You might need a trailing backslash or slash.
Oh, that is exactly what I need. Thank you. That is the biggest gotcha with URLs. And indeed, we have a trailing backslash here and here and here. And we'll see why we need that trailing backslash in a minute. URL pattern my home has a route beginning with the slash. Remove the slash as it is unnecessary. So Django is actually helping me here. I don't need the beginning slash. That was my other mistake. And admin, you'll note, doesn't have a slash at the beginning either. You kind of need different slashing in different spots. So it can take a little fiddling. But now we've got my home.
Yeah,
But
what
yeah,
what I was getting to was like, for example, like trying to pull up the routes for line 40, 44 for you couldn't do without the, the home path being defined.
pull out the routes for what?
I mean, what I'm saying is like if I wanted to like just comment out home, I couldn't pull up 43 and 44, the paths when I typed them into the web address.
Oh, well, let's see here. So first of all, let's look at admin. And if I comment out home,
Yeah, you can do admin, but I'm saying you couldn't do the other two without having a home path defined.
let's see here, square with a height of 4. So I think you may have been running into some other issue. I'd have to look at the code.
That's all right.
Yeah, yeah. But I did want to point this out because that is a good question. But these are not dependent on each other. These are each separate paths, right? And with this line commented out or missing, this is like a big if statement or a case switch, and Django does pattern matching to see it's looking at this here and it's pattern matching against each of these, right? So I did want to come to that so we could see that behavior. So that is a good question, and it is good to be thinking about this stuff. But yeah, you should be able to comment out or remove one, and then the other should work. There's probably some other issue lurking in the code. I know this URL pathing stuff is a bit newer. Are we starting to get a bit more comfortable with it? Cool.
The path and views from yesterday were probably the easiest part of the assignment.
Okay, awesome. Let's add some fixtures and then let's start making more views. So I think we can leave the server running. Well, we're gonna have to load fixture data anyway. I think we can leave the server running. So I want to add some moves to the database and I want to add it doing fixtures. What do I need to do that? These are the only fixtures we have right now. And I want fixtures to create some moves, and maybe we can even then add some moves to some of our Pokemon.
Uh, I'm not exactly sure, but can we do it with the admin page?
We can, but that's not the way I want to do it. I want it in the source code so we can run from the command line, the command to load fixtures into the database. So it's really easy to spin up a database with Pokemon and moves. Because I might need to drop the database while I'm writing code and I want to rebuild it. So I really want to create some fixtures for moves and put it in the database. So how do you create a fixture, period? What's step one?
You need a fixtures folder with a JSON file inside of it.
Yep. So we're definitely going to need a fixtures folder in here. We need a JSON file. What do we want to name this JSON file for our moves?
moves.json.
Yeah, I'm going to name it movesdata.json just because the other file is named Pokemon data for naming consistency, but both names are equally good, right? I'm going to pull up a split here and let's put our move model on the left. And in fact, let's also put here on the left as like a friendly reminder our Pokemon data. So what's the first thing I need to add to a brand new fixture file?
A list. So square
Yeah.
brackets.
And I see there's a bunch of dictionaries in here. What keys, what properties does this JSON object need to have for Pokemon moves?
Well, first you have to like define the model that it's going to be mapped to, and then primary key.
Yep. So like this?
No, like where it says Pokemon underscore app dot Pokemon, it'll be like that, but using the moves app, yeah.
Yep, looks good. Yep, you're absolutely right. We need to manually create a primary key. I think I need fields if I'm looking at the pattern here. And let's pull up the moves model. What are like what's like the one most important thing we need here that we're gonna add?
The name.
Yeah, I think we need a name. And I do need some help here because I have no idea what Pokemon moves are. So give me the name of a couple Pokemon moves. What's the name of a move?
Should you put them in a list, right? But flamethrower, you got
Water punch.
Flamethrower, awesome. Love it. I'm gonna copy this whole thing. Someone said water punch. Jack, I think you were gonna say another one as well.
You
tackle.
do Thun.
Sorry,
I said tackle.
tackle. And Chase, what was the other one you were saying?
I was going to say like Thunderbolt.
Thunderbolt. Love it. Classic.
What is a water punch though?
Never heard of that move.
Okay.
Is a punch made of water. There's also fire punch.
And we got to change the primary keys. So we're incrementing. And fingers crossed, we've got some Pokemon moves. Remind me again, what's the command I need to run to put these Pokemon moves into the database?
Isn't it like load data? So like Python, manage py, yeah, load data, and then the path to the fixture JSON.
Yeah, very close. It's confusing. I wish they had done it this way. The Django people wanted to be clever and save time and thus become unintuitive. We actually don't need the path, we just need the file name. It's a massive gotcha. And let's see here. Serialization error, problem installing, blah, 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 blah. Invalid model identifier moves app moves. If I had to guess, anyone, well, I want to tell me what I did wrong here?
The S.
Yeah. Yeah, the class name is singular. I got ahead of myself. I used the plural in the model name. Um, Again, with error messages, it's often the top or the bottom of the message that the useful bit will be. Note that there's also no installed app moves app at the top of the error message. So I in fact have two mistakes in one here. So let's run this again so we can watch the other error message happen. And it's tricky because we still see invalid model identifier down here at the bottom, right? But I fixed move. But if we go up to the top of the error message, we see lookup error, no installed app with label moves app. So this is why it's not quite at the top. Yeah, there it is at the top. It's really important to get in the habit of looking at both the top and the bottom of your error messages. Because as this stuff gets more complex, it's more and more common where you have multiple bugs that are causing a problem. So fingers crossed. There we go. So by the way, my server is still running. None of this impacted the server. We were able to talk to Django and run some code and talk to the database. And now if I go and we look at our moves, select star from move app move, we've got our moves in here, which is awesome. And now I should be able to go to my admin site and look at the moves, and we see the moves in here. I should have left the network tab open.
I am sorry to go back to a question from what we just
Yep.
passed, but
Absolutely.
I know you said you can just put the instead of the path, you can just put the name of the file. Is
Yeah.
it not still like path oriented in a way, like depending on, I guess, where you're accessing it from?
Good question. With all of these commands, and we have to be in the same directory as manage.py. We also have to have the virtual environment activated. For other commands, you may be correct. For load data specifically, Django will look for a directory named fixtures in every single app and look inside those directories for the file with this name.
Thank you.
You're welcome. Yeah, I honestly don't think it was a good design decision on their part because it's not consistent with other ways of doing things, but that's how they decided to do it. So this is awesome, right? Now, by the way, if I wanted to add some moves to my Pokemon fixtures, how could I do that here? Like, let's give Pikachu a move and Charmander a move.
In the model, wouldn't you be adding like a one-to-many connection?
We absolutely would be. And I think I'm going to pull out, we'll bring back the side view later. But if we pull up our Pokemon model, we have already added, in fact, it's a many to many, as a Pokemon can have multiple moves, and a move can be used by multiple Pokemon. So the model work we've done, we may not have seen this. How do I represent a relationship in a fixture? So let me just code this up, and I hope I get this right. I might get it wrong, frankly, but it'll be easy for us to fix. I believe we do it like this. That should give Pikachu two moves. The moves with IDs 1 and 2. And let's give Charmander also two moves, 2 and 3. Now, I already have, Pikachu and Charmander in my database. So if I run load data Pokemon data, I think we're going to get an error. Actually, we didn't, which I'm a bit surprised by. So I'm very curious to go here into pSQL. Actually, let's just use Django admin because it's a bit faster. I think we're all comfortable with the relationship between the models and the database. Let's look at Pikachu and see if the moves were added. And indeed, down here it moves. These two are in yellow. So I am going to make an SQL query because I think I understand what Django admin is telling me, but I want to be really sure. I wish it was a bit easier to use the up arrow there. Well, this isn't really the right table for me to be looking at. If I look at all of my tables, well, actually, what table should I look at in the SQL to see what moves belong to what Pokemon? It's not all this built-in Django stuff, right?
The Pokemon app moves.
Wouldn't
Uh,
it be Pokemon app, Pokemon moves?
Yeah, that one.
Pokemon at Pokemon moves. Yep, I think you are correct. Now, do we have a model for that table?
No, but Django should have made it.
Yeah, exactly. Right. And this is where like last week we had to make a join table like this for a many-to-many relationship manually, and now Django makes this for us. And so now this is really nice because I can drop my whole database and in like 3 commands, apply migrations, run moves fixtures, run Pokemon data fixtures, have everything set up. Hypothetical question. Let's say we dropped the database and we did rebuild it. Does it matter which fixture file I load into the database first?
Yes, because you would need moves in order for Pokemon JSON file to understand what the moves is looking
Yeah.
up.
Yeah, exactly. Right? We've got this relationship dependency here in our fixtures because if I install the Pokemon, but we haven't installed the moves, we'll get some sort of error saying like these keys like point to something that doesn't exist. So as our data model gets more complex and we make more fixtures, we do have to kind of keep that in mind. All right, I've been doing a lot of talking, a lot of review. Let's start talking about views. Do we feel kind of like warmed up though with our brains in Django mode now? Okay, awesome. So to talk about views, we have to talk a little bit about APIs. The acronym API stands for Application Programming Interface. It gets used for all sorts of stuff that's not necessarily about Django or like the Pokédex. But whenever we are using it talking about web stuff, we're almost always talking about what's called a REST API. REST is another acronym. It stands for Representational State Transfer. Don't worry about that. It's kind of an overloaded term. It's literally an idea that someone came up with the late 90s of how we can use HTTP requests but organize it in a better way to get data from our database. And the good news here is that you all have already seen a REST API in action. The Poke API is a great example of a REST API. And this is sort of like the standard way that that servers are organized on the internet. Because the beauty of this Poke API is I can write whatever kind of program I want, Python on the command line, JavaScript in the browser, React.js, a mobile app, and as long as it can send an HTTP request and follow the conventions of a REST API in making HTTP requests with the right verb and the right URL path or route, we can get data from the Poke API. And like, my React.js program doesn't have to care if Poke API is using Django, Postgres, or, like squirrels running on treadmills to get the data. And so the REST API sort of abstracts stuff. And a REST API has a convention around how to use the HTTP verbs. Get is for getting data. Post request is for creating data. We'll see that later. There's also a delete request and a put request to update. And then this pattern where you see all this, you'll see the host name or the IP address. You'll always see like API and then usually slash V2 or V1. And this is because maybe thousands of people are using the Poke API site and it's on their websites. And maybe Poke API needs to change this. It needs to change the name of this to Pokemon ability. I don't know. But now with thousands of people using our API, when I change this, excuse me, it will break all their code. So what I do is in my URL, and this is sort of like namespacing. I version it. If I needed to change this as the Poke API maintainer, what I would do is I'd roll out a new version of the API slash v3, and then this would be like a Pokemon ability. You know, maybe also other stuff has changed, so it's not just the name, it's how you use it. And I would still have the old v2 version, and that way I have backwards compatibility with other stuff out on the internet, but I can still change and move forward. So this is sort of boilerplate, but that's what it's there for. And then as you can see here, we have the route to the resource or the thing that we care about. And as you all can probably imagine now, if we were building the Poke API with Django, we'd probably make an ability model, right? And there'd be, in fact, a Pokemon model, there'd be a moves model, a location model, an item model, a game model, an evolution model, a berries model, and so on. So the name in the URL represents a resource, right? A thing that we care about, an entity. And it's usually something that is in the database and that we have a model for. And what you see with REST APIs is sort of like a hierarchy. So you might see get API v1 Pokemon. And what this does is it gets all Pokemon. And you might see API v1 Pokemon slash, and this colon, this is a symbol for a variable. The actual HTTP request would have an ID, right? Get Pokemon with ID of 1. Maybe we also have get API v1 moves, right? And that gets all moves. That's how I could get a move with ID 3. And then we start to sort of see these things combined. And I'm going to run out of space here. And this is where it gets interesting. And you can sort of see a hierarchy here, right? Out of all the Pokemon, get the Pokemon with ID 1, and then give me all their moves. And this would give me all the moves belonging to this Pokemon. And do you all sort of see how we can organize the relationships between stuff by using URLs this way? This is like the essence of a REST API, and this is the pattern. And you'll hear a Pokemon and a move called a resource. And you know, it's the same way, like we have a Pokemon model, we have a Pokemon table, we'll probably have a Pokemon component in React. In this sort of abstract sense, we call it a resource. And this is how, by using URLs, I can use them in a certain kind of pattern to get whatever I want from a database if someone else is writing their backend Django server code following this same pattern. And this is the idea of a REST API. And then, if I wanted to like delete a Pokemon, I would do API v1, Pokemon of ID 1. If I wanted to create a Pokemon, or let's say modify a Pokemon, it would be API v1 Pokemon ID 1. But then in the body, once you start adding stuff, you're almost always sending JSON. So, maybe we want to add another move to my Pokemon. And so we'll see this later, but in the body of the HTTP request, our AJAX request with Axios sent to the server, we would have some JSON sending stuff. And so you can see how the URL pattern is the same for the resource for Pikachu, right? For our Pokemon with ID 1. But by changing the HTTP verb, we can do different things to it. And we can do what's called CRUD, which is create, read, update, delete. And I can write a Python program to talk to our Django program to do this with HTTP requests. I can write a mobile app with React Native. I can write a React app in the browser. The beauty of the REST API is it doesn't matter what the client is, as long as it sends an HTTP request in this format, we're good to go. There's more to it than that, but this is the heart of it, and this is by far what you'll see the most. So I've been doing a lot of talking, and I just want to pause and check in and see what questions folks have. How are we sort of feeling about this?
How does the server know that we want to get instead of delete with a URL? Because
Right,
those look the same. How do we know which verb it is?
right. Good question. When the browser sends an HTTP request to the server, it sends more than just the URL. I have to go all the way up here, but if we look at this HTTP request, I don't think it's in the request headers. It is in the request headers. So actually, let me just copy, and we'll copy as curl. Curl is a program on the command line for sending HTTP requests. Like I can do curl https www.google.com. And what we get back, this is a ton of stuff. But if I scroll all the way up, it's kind of hidden. We're getting back an HTML page. This is the HTML of the Google homepage. So curl sends HTTP requests from the command line. You can do a lot of fancy stuff with it. And the network tab has this pretty amazing tool that will take that HTTP request and kind of turn it into a curl command. And I know that's a bit hard to see. Let me clear it and paste it so I think we can see it like this. So this is a lot of stuff, right? Don't worry about it too much. What we've got going on here is this is the URL we're sending it to, but then every -h is like a header, a different request header. And by default, this is a GET request. So this is like actually an HTTP request and what it looks like. And then if I can just get the Zoom annotator to stop bugging me, we can send our HTTP request. And it's a little hard to see, but down here, right all the way at the bottom, that number 16, that was actually our Django server sending us the HTTP response of 16. So the HTTP request includes more than just the URL. It also includes the method or the verb. And if I copy this as, let's copy it as fetch Node.js. And like if we wanted to just copy the request headers, it lets us do that. And in fact, let's open up a text file. My request.txt. So we don't need that. So if you just right click and go to copy, this is a pretty amazing tool. And these are all of the headers in our HTTP request. So all of this gets sent along with the URL, and that's where we send the verb. And in fact, you can see in this header, it has the URL as well. So this is sort of the full request. So this is kind of peeking under the hood a bit, but I think it's really good to see. And in fact, I'll save this and we'll call it get square.http. And you can in fact save this as a .http file. There's actually a pretty nifty VS Code extension that will actually send a request. Like let's make this instead of 416. So this is also sending this HTTP request to the browser. I'll send the VS Code extension to it later. I think it's just called requests, and it's pretty cool. And just to show this, I think one other way, let's see this as with Node.js with, it doesn't have Axios sort of built in, but it does with fetch. So let's save this as get square.js. And here again, this, right, what we've seen is axios.get, but fetch is doing the same thing where we have our URL parameters, all of the different headers. There's no body, there's no JSON. Like if there was JSON, this is where it would go. And then down here, because the HTTP method is so important, the people who wrote fetch gave it its own property here in this like giant object that we're constructing this with. Does that help answer your question, Kenny? And is this helpful and not too much information overload for folks? How are we doing?
It sort of answers some questions, but I feel like if I ask any more, it would just be going out of scope.
Yeah, I do want to make sure. I do apologize. We're probably going to run. I'm going to eat into the work time a bit today. But we've seen kind of the big pieces here, and the main takeaway is an HTTP request is not just the URL, it's also the verb and a whole bunch of different headers. And in fact, when we start dealing with authentication, we'll have to be adding more headers. And that we can, because of that, we can organize the way that we send HTTP requests in a really consistent way. And this pattern is what's called a REST API. And it's just like a set of patterns and conventions to follow when we write a backend server. I realize we haven't written any view code. It's also 10 till. Why don't we take 10 and then we'll come back and we'll start writing code. Sound good? All right, awesome. Thank you very much, everyone, and I'll see you all in 10 minutes. Yeah, I hope everyone's doing good. I got my coffee over here, so I'm doing good. We've been talking a lot of theory, but let's put it into practice. I might ask for a little help along the way to do this, but instead of /square, let's do /API/v1/Pokemon. And what I really want is I want to get all of our Pokemon. So I know I'm going to need some sort of function, a view function, and I know that it needs to be passed a request, even if we're not using it yet. But I'm not sure what else to do with it. What's the next step here that I need to do?
Create a path in the URL patterns.
Yeah, I got to create a path.
I got a question real quick.
Yeah.
Are you just putting these methods here, these functions here, just for demonstration purposes? Because to me, it doesn't seem natural to like throw them here like for like normal use.
Yeah, great question. That's exactly what we're doing. We're gonna build it here, and then I'm gonna show you how to put it somewhere else. Exactly. So we're gonna build our path API slash v1 slash Pokemon, and I want this to give me all the Pokemon. I know the second argument to this path function needs to be the view function. Okay, good enough. If I refresh my page and this is my workflow, I get a different error. This is progress. I get a value error. The routing didn't fail. And in fact, if I go here to Python, let's go ahead and clear this and clear the network tab. And this is your workflow when you're doing this. We see internal server API v1, blah, 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 blah. The view Pokédex, all Pokemon didn't return an HTTP response object. It returns none. No problem, right? Sort of iterative development, sort of test-driven development. Let's fix that problem. And my server did die on me because of the error. Oh no, it's still running because Django's great. So I can run it again, and now I get all the Pokemon. But this isn't very useful, right? What do I have to do to actually get all the Pokemon? How about in source code? What do I need to do here without worrying about like writing the actual code?
Then you need to do the API call for it.
Well, the browser's making the API call now when it sends that GET request over. That is indeed, let's go all the way up here. This is our API call, right? Get Pokemon. How do I get data from a database in Django?
Select query.
Models.
Writing SQL, but what have we been doing the past 3 days?
Models and
Serializer.
serializers.
Yeah, models and serializers. Exactly. I got to use the Pokemon model or serializer to get the Pokemon from the DB. So let's start with the model. Let's keep it simple. What is, someone remind me, is it actually objects all, or am I losing my mind?
Yes.
Yep. And this red squiggly is reminding me I need to import. So we'll import from the Pokemon app models. Import Pokemon. I'm going to do a little debugging here, just so I know if I'm doing something right or wrong. And this is going to be your workflow as time goes on. Like you're constantly going to be hitting the refresh button in the browser. You can also use, there's libraries that we'll see later, but this is great because I see that indeed I got my Pokemon. Now I have to send the Pokemon back to the browser in the HTTP response. What do I have to do with this data before I can do that?
You need to serialize it and send it by converting it into JSON.
Yeah, exactly. Right. I need to turn it into JSON. But to turn it into JSON, I need to use a serializer to turn the model objects into dictionaries. So let's go ahead and do this. I'm going to have to then also import my serializer. And let's do all Pokemon serialized equals Pokemon serializer all. And what do I have to do when I have more than one thing in my serializer?
Many equals
And
true.
equals true.
Yeah, exactly. This is one of the biggest gotchas. This is by far the biggest gotcha with the serializer, I think, is for getting many equals true. It can drive you nuts. And let's print this out too, right? Why make life hard? Let's print it out and see if I got that line of code right. And there's a whole bunch of stuff here, but I see the serializer is doing its job. I did. This is great, right? So I've used the serializer to turn it into dictionaries. Now we need to turn it into JSON. And I am going to import another handy dandy class from, I believe it is Django REST framework to do that one. And let me make sure I have this right. Yep. So from Django REST framework, or actually, I think we can just import this from Django HTTP. They have a JSON response class. I think Django REST framework might have one as well, but we can worry about that later. And let me make sure I have that spelled right, because I think I do. If all the letters in JSON need to be capitalized, we'll know if we get an error. Let's return a JSON response with all our serialized data. And now we should be home free. Almost. I have a type error. It says to allow non-dictionary objects to be serialized, blah, 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 blah. I need to change this a little. First of all, how do I get the dictionary with all the data I want inside of my serializer?
Dot data.
Yeah, exactly. I want dot data. So let's run this again. We see the error, but we also see all of our awesome Pokemon information, including the moves, because we've added some move serializer stuff. We're still getting this type error. And our final step here to take this home is we just need to wrap this dictionary. Probably because it's in a list. And now let's try this one more time. And now we get back all of our Pokemon data. So we use the model to get the data from the database's objects. We use the serializer to turn it into dictionaries. And then we have to turn the dictionaries into JSON. And Django REST framework actually does give us a class that will alleviate some of this pain. It's their response class. And let me make sure I have the right interpreter set, because I'm a little surprised that it's not. I'm not going to worry about it right now. I'm going to ignore the squiggly. I'm like 99% sure this is working. But what we should be able to do now is, let me just comment that out. We should just be able to do return response all data, or all Pokemon serialized data. And let's see if that works. Accepted renderer not set on response. Yeah, I may have gotten my head ahead of myself a little bit. We'll come back to this one. This is when we turn this into a class that will work, and this will become easier. But this is a good pause point, because we have now sent back our data. And in fact, if we look in our network tab here and we go all the way up, ignoring all this other junk. Let's in fact clear this, refresh, and let's filter for API v1 Pokemon, which makes it way easier to find our HTTP requests. And we can see here the response from the server that has all of our Pokemon moves. So I just want to check in and see what questions folks have here, because we didn't see anything new, but we have combined it all together in a new way.
How do you have that pretty print box like that where you can like check it and uncheck it?
Chrome just did that for me. It's a part of Chrome. I don't think it's an extension or anything. By the way, if you're not using Chrome as your browser, I strongly recommend it. It's pretty much the standard for front-end development. And as you can see, their developer tooling in the network tab and everything is pretty incredible.
Regarding line 41, you had to wrap it in like a dictionary because it can't use JSON on like a list, right?
I think so. I think I'm like 99% sure that was the issue, yes. Because we see here it's all a list. And I think the JSON response wants this to be a JSON object. But don't quote me on that. And to be honest, this is going to get simplified in like 5 minutes when we turn this into a class. How are people feeling about these key steps of I create a path, I have a view function, I use the model to get the data I want, I use the serializer to turn that information, those objects, into a dictionary, and then I use like JSON response to turn that into JSON and send it back as the response.
I definitely understand what you're doing. My real question is the line, what line number are you on? Line 34. Is that just getting the model or is that taking from the database?
Great question. This is querying the database.
Okay.
Yeah,
That makes more sense because the model wouldn't have the data inherently with it, even if you used a fixture.
exactly. And remember, like we would do, if we do get, name equals Pikachu, our model is querying the database for us to get this. And then we have this nice helper method, all that will just get everything. Why we have to do dot objects, I don't know. That's just how Django made it.
Regarding like API calls and stuff, and this may be like obviously a
Yeah.
little out of scope. If we wanted to make it so we don't have to do an actual API call over the internet each time, like say with the Pokemon API, could we just then take that JSON data and write it to a JSON file so we have it in our project?
Are you talking about for our Django code or for your React app on the front end?
Yeah, like the React, like so, right? If you
Got it.
like,
Yeah. No, I know what
is
you
that
mean.
like something we could do? Is like take that JSON data and write it into a JSON file in our own project?
You can, absolutely. And that's actually really good for fake data to help with testing and development of your front end. But the thing to think about here is let's pretend we're Nintendo and we're adding new Pokemon all the time and we're making a Pokemon game. I need my React app to be able to get like the new latest and greatest Pokemon. And so when we're learning, we don't think about the data constantly changing, but for when we actually build stuff, it is.
Okay, so it's good for like static data that's like not ever really going to change.
More or less, yeah.
Okay,
Yeah.
thank you.
Totally. There's also caching, but that's a little out of scope. Yeah, great question. Let's go ahead. Let's take the next step now, because I know that we had a lot of theory before, and I want to make sure we have a bit of a break and cover the ground we need to. Let's move this out of here, because Jason, you are totally right. Like this URL's py file, it's getting pretty crowded, right? And it's getting a little messy. And let's make this a bit cleaner. So we have to mess with URL patterns. And what we're going to do, and let me kind of get a little room here for a split and just sort of clear the decks a bit here. sorry, I was muted. What we're going to do is here in the Pokemon app, we are going to make a urls.py file. And so the pattern then becomes the urls py file in the project. Its job is really to point to other urls py files, right? And if when we build the API to get moves, we would do the same thing and we would make a urls py file there. We're going to see how to do that in just a sec. But does that concept make sense that, like, it's like a forwarding address, right? We might start at the big project level urls py, but it's going to send us somewhere else. And in fact, if we look at this admin path, we can kind of see that happening. This is not a view function, right? This is the admin app that was installed by default with Django. And there's some urls py file buried in the Django source code that has all this stuff. So somewhere out there is things like admin/home, admin/login, and so on and so forth. So let me do a little bit, let's do a split here, in fact, and I'll do some boilerplate and setup, and then we'll see, and then we'll make the switch. So I need to do some importing. From Django's URLs library, we need to import this path function. That's really the main thing. We're going to do a bit more importing in a minute. I have to create a list named URL patterns, just like we see in the main URLs PY. This is just how Django works. And let me bring this up here so we can get these two together. We're so close. There we go. And let's close this out so we can see this a bit more easily. Because here's what's going to happen. And let's put this right here. What we're going to do is this. Include Pokemon app.urls. And I almost definitely need to also import include now. If I hop up here to Django URLs, let's import include. And so this is loading this whole list here. So what this in fact is API v1 Pokemon. And I in fact want to take my all Pokemon view function, and we'll kind of do more manipulation of this in a minute to put it in the right spot. Because this is indeed going to live in our views file in just a minute. But let's just do this step by step. And so fingers crossed, we should still have this be working. And let me just restart my server. Just sort of for my own sanity. The Django server is really good, but every now and then you have to restart it when you're like, if you change settings PY, you definitely have to restart the server. So let's see if this works. If I hop over here to my same endpoint, we get a name error. JSON response is not defined. I forgot to import from Django HTTP, import JSON response. But now this is working, right? So what I've done is this now points to this other URL patterns over here. And if I wanted to, this is just an example of how this works to add on to it. We obviously would want this to do something different in reality. Let's see here.
I believe you're missing a closing slash on that URL pattern.
Yeah, thank you, Francisco. Yeah, I was just
On line 36.
oh. Yeah. There we go. Thank you so much. Yeah, so this one is not needed. Actually, that one looks like it is needed. The slashes always drive me a little nuts. And so what we have here is API/v1/Pokemon/more stuff. And this isn't so interesting, right? But maybe we want to do API v1 Pokemon ID moves. That we'll come to that later, but you can see how the main URL pattern in the project URLs PY is added to the additional URLs pattern here that we make in the app directory. How are we feeling about this?
So the urls.py in the Pokemon app is appended onto what already exists in the urls.py, same path
Exactly.
in the project.
Exactly.
So you need both.
Exactly. Exactly. You need both. We start with URLs PY in the project. When we say include, we say append to this whatever's in here. You can think of it, it's like if I went to your house to find my friend and you were like, yeah, he's not home, go to Jacob's house, right? Include says go to Jacob's house. And then it continues kind of doing the pattern matching. We can sort of see this in action if we print request headers. Let's see, I think it might be, yeah, I wanted to show the URL, but I think it's a little hard to see in here, so we won't worry about the request headers. Let's refactor this some more because it sure would be nice to have this not live in URLs PY and actually live in views. So this is the views PY for my Pokemon app, right? We already started kind of thinking about all Pokemon, but now that we've built it, let's take it and put it here and import what we need from .models, import Pokemon, from .serializers, import Pokemon serializer, and from Django it's an HTTP, import JSON response. And now over here, I can really clean this up, right? I just need to do from .views, import all Pokemon. And fingers crossed, let's not test the more stuff endpoint. And I think I'll get rid of that one to avoid potential error. That still works. They both in fact work. And so now we have, to go back to your question earlier, Jason, we have like a much more nicely organized project, right? I have my project level URLs py. It doesn't need to import models or serializers from apps. We start here with our pattern matching. If the URL matches, as you said, we go here and then we would append and continue our pattern matching. And indeed, API/v1 Pokemon matches here. And so we then call our all Pokemon view function. I just want to check in and see what questions folks have around this. We feeling pretty good, or what's on people's minds?
I guess I kind of feel like it's another process I'm gonna have to streamline, kind of like how I've been trying to streamline my process getting project going. I'll also have to streamline my process of, creating the new urls.py file, the function in views, importing it to the urls.py in the app, and then getting it to the adjusting the urls.py in the project. Kind of like streamline the process. I don't have to like think about it so much every time.
Right. And once you get used to it, it's a pattern. And I'm going to get rid of the sidebar here so we can have a couple splits. And let's open up our Pokemon views. And let's open up the other URLs py in the Pokemon app. And this is why programmers love having multiple monitors and big screens so they can do splits. Like we're a little cramped here, frankly, with the browser. Normally, I would just have that somewhere else so I could see all three really clearly at the same time. You can also like split horizontally across the screen. I just really like vertical splits. So this is the flow, right? When I make an HTTP request, it starts here, it gets routed over here, and then it gets sent to the view function. It's much more straightforward to set up. I kind of took us through all the steps, but let's take one final step now and let's convert this into a class. And I'll leave this here and we'll call this our function-based view. And this, by the way, is sort of where this like model view controller term comes from, because you can start to see how the models and the views interact. Let's make a class, and we're going to use Django REST framework to do this. And Jason, this is sort of the final form. So we need to import an API view class from Django REST framework. And from Django REST framework, we need to import a response class. And we can make a class named all moves. It's going to inherit from this API view class. And we want a method for each different HTTP verb. So this is going to be triggered by a GET request. And we have to name it GET, the name of that verb. And we're going to do, oh, I'm so sorry, folks. I'm giving this the wrong name. This is all Pokemon. We're not at the moves yet.
This is in the same view file that you would have otherwise put
Correct.
The thing you just had, you're just refactoring it into a class.
Exactly. Exactly. Like I'm leaving this code here as a reference for you all, but this is the way you all should be doing it.
Okay.
Yeah, great question. And in fact, we're going to do pretty much exactly the same thing. I am going to condense the code a bit. Let's, in our Pokemon serializer, just grab all the objects. Let's in fact use order by to get all of them and order by name. And let's say many equals true. And then we can finally use the really handy dandy Django REST framework response class, so we don't have to do as much dancing with our data and like wrap it in a dictionary like we did with the Django REST framework one. We still do have to do Pokemon.data. Now let's hop over to URLs PY for our Pokemon app, and let's use this instead. So let me import the right thing. And I do have to do one special thing. I have to call a method on it called asView. And that will create an instance of this class and set it up so that later on we'll have different methods for post requests and delete requests, so that when a get request comes to this URL, and let's put these down here so we don't have to worry about them, it will call this function, right? So our function-based view is sort of here, but it's wrapped in a class now, and certain things make our life easier. And then the last thing we're going to do is for Django, give this path a name, which will help for us in debugging and writing tests as a quick and easy way to refer to it. So fingers crossed, this refactoring has worked without an error, but let's hop over to the browser and give it the test. And indeed it's worked, and Django REST framework, as we can see, actually gives us some really nice debugging tools. We can see the important details of our HTTP request. We can see the HTTP response code and some of the important headers, and they really pretty print the JSON data. And if we had like, more options here, we could kind of fiddle around with them. So that's the great part about Django REST framework and doing this as a class. So this is kind of where we were ending up today. These red squigglies are just, I need to select my Python interpreter, so don't worry about that. But this is really the journey that we've been going on, right? Where, in fact, let's do, is it WV?
Yeah, so I noticed in line 7, I guess .asView is not a function that has to be imported in. I guess it's already included with Django.
It is a part of this APIView class.
Oh, okay.
Yeah, good question. Yeah, in fact, and if we go to Django REST framework APIView, it's definitely worth a little bit of time looking at their docs. Somewhere around here, they should have an API reference for APIView, but they have a tutorial on pretty much what we just did. You can sort of see here when we get to HTTP put requests and delete requests, we can start adding more things. We can get like an individual thing, but we'll get there later. And somewhere floating around here are the and like if you go through the docs here, they'll give like a full breakdown of that APIView class. And we could find asView, which is floating around here somewhere. I don't want to get too lost in the docs. What questions do folks have, and what's on people's minds?
Could you expand line 12 on the views.py?
Right here, the Pokemon serializer? Yeah,
Yeah.
absolutely. So line 12, and I'll bring up the other code so that we can reference it. In our function view on line 22, we did one query to get all the Pokemon, and then we stuck it into the serializer. I combined that all into one line, but instead of just getting all the Pokemon, I said, make sure you order them by name.
Okay. I get that. What replaced the all equals Pokemon.objects.all?
Pokemon.objects order by name.
So that's automatically inclusive of all. It's not going to just grab one.
Correct. Good question.
Okay.
Yeah.
How would you refactor this class to only grab one based on its name?
Yeah, great question. what we would do is, in fact, this is getting a little more advanced, but let's do it by, yeah, let's do it by name. We would make a path. And the way to do this is pseudocode first. This is what I want, right? API one, B1, Pokemon, Pikachu. We're gonna have to think about uppercase and lowercase, which is gonna be a pain in the butt, but we'll get there. And let's do string, and let's just call it name for now. And fingers crossed, that's the right format. If I could just get my single quote in the right spot. Because like you were saying, Tim, this gets appended to the API v1 Pokemon from the main URLs PY file. Right? Does that make sense to folks? In fact, let's TL draw that real quick. Where, and as Francisco, he says, everything is boxes within boxes. So let's do, you know, our two boxes, and we've got URLs PY, and we've got Pokemon app URLs PY. And then over here, you know, we have URL patterns. And I'm not going to write out all the stuff. I'm just going to write out the pattern just in the interest of time. And, you know, over here, it's, and so on and so forth. I probably should have written out the whole pattern, but we can at least get the general idea here. So once we do the pattern matching here, it goes here to do more pattern matching, right? And appending. And so we have our other URL patterns. Let's put this here. Our main project URL patterns, and then it goes here to append, right? And we had that one, but now we're adding this one that's going to look specifically for a name. And now I've got to write my view function logic for that, right? The easiest way to do this is actually to make a separate class. I think there's a way to add it onto the class-based view. I'm actually a little less familiar with it, but let's just call this a Pokemon for an individual Pokemon. And we know that we are going to get passed in as an argument name. So let's just print our Pokemon name just to make sure we're getting the right data. And then I would just do Pokemon objects.get name equals name. This is no longer many, right? So we do need to modify that. And fingers crossed, that's going to do it for us. But let's run our code and see how we do here. So it's now no longer v1/Pokemon, it's Pikachu. And it looks like, did my server die on me at some point? Missing one required positional argument view. I missed a key step here, folks. If I hop to my other URLs PY, and I hope I'm not hopping around too much. What do I need to add here to this new path?
You need to add what you're linking it to.
Yeah,
So
and
probably your A class, your A character class, or A Pokemon class.
exactly. We need to import a Pokemon. And then to do it the way Django REST framework needs us to, we need to do as view. Let's do name, and we'll just call it like Pokemon or a Pokemon for consistency. Now, I might have some other errors along the way, but that error is resolved. I am gonna stop and restart the server, and let's try this request again and see what's going on. It looks like I forgot a slash probably at the beginning of this is the issue. I always seem to be forgetting the
The
slashes.
end.
Oh, at the end? Yes. Because the slashes drive me nuts. And this is where does not exist. So we made some progress. If we look here, we have our get request. I'm printing out the Pokemon name here on line 13. So that tells me my routing code is good. And then I get an internal server error, blah, 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 blah. Matching query does not exist. My guess is I have an error. Frankly, we may also have to deal with Pikachu being uppercased in the database. So let's do Pokemon equals Pokemon objects get name equals name, and we'll call this serialized, and we'll pass in the Pokemon, and we'll call this serialized, and we'll print out our Pokemon. And this, I just took one line of code and broke it into three, right? And this is how you debug something like this, so I can isolate the error. And now if we look here, Pokemon name Pikachu, but we certainly don't get to getting our data back, and we get matching does not exist. I think this part's correct. I don't think I'm getting this wrong. Another good debugging technique is hard code your data in to make sure your logic is working. And that is working just fine. So that tells me that my hypothesis was confirmed, that the problem here is in the database. Pikachu starts with an uppercase letter, which is a pain in the butt. I actually have to ask ChatGPT how to have this name search be not case sensitive. I'm not quite sure how to do that, but the lazy approach here would be can someone remind me, in Python, does dot capitalize the first letter of a string?
Can you do just dot title? Doesn't that just capitalize the first letter?
Yeah, it does.
Yeah, I think that's what we want. So let's try. Actually, I need name dot title. Let's see if that does it. And now that works, right? But really, this is not a good solution. Really, I want to do a Google search and see how to make this be non-case sensitive, but that's a little outside scope. And that's also a great example of why case sensitivity, when you don't need it in your data, in your database, is bad. But yeah, great question, Tim. And this was great to walk through. Why don't we take one more question and then we can break, as after this, we'll be adding more on and also looking a bit at testing. So what else might be good to see to kind of recap this whole flow before we break? Should we?
Could you just like not necessarily go in depth, but could you just like go over the flow again?
Yeah. Yeah. And in fact, I was gonna say, should we build this for moves, for a move?
Yes.
You want to do that now, or you guys want to break first?
Maybe break first.
Yeah.
So yeah.
Yeah, let's take 10. We'll come back, we'll build it for a move, and then we'll expand. All right, folks, thank you very much, and I'll see everyone in 10 minutes. All right, so we're gonna add some code for moves. But before we do that, let's kind of trace the flow of execution here. Oh, yes, what's up? Let's say we get an HTTP request in. Pokemon, and in fact, that's it. And that's our HTTP request. So how does Django handle this? Django takes this HTTP requests and it sends it to the main URL patterns in our main project URLs py. And it looks at the URL in the HTTP request and it does pattern matching until it finds the first match. Now, over here, if we had a view function, it would run it, right? But we don't. Instead, we have a forwarding address. And that says to Django, okay, cool. This matches, but what I want you to do is do more pattern matching. Go over here. And Django, the order of something in URL patterns actually matters because when Django does its pattern matching, it's like a bunch of if statements. It goes top to bottom. And so Django first tries to match here, right? And it says, well, do I have API, let me uncapitalize, API v1 Pokemon Charmander, right? Is there, because that first part there has to have something here to match the pattern, or, it could be Eevee. And it doesn't. The URL is just plain old API/v1 Pokemon. So Django goes on to the next URL in the pattern to pattern match there. And it says, yes, lo and behold, we do have a match. Right? All right, what do I do now once I have a match? Well, this asView method basically has created a bunch of little view functions for us. And Django now looks at the verb in the HTTP request and it says it's get. Okay, well, I better call this get method over here. And this is what we were writing just now that uses our model to talk to the database and the serializer and do all this stuff. And then it returns an HTTP response, right? And this goes all the way back to the user's browser somewhere else on the internet. And, the response is going to be something like, 200, okay. And in the response body, there's going to be a JSON list, of different Pokemon. And all our different Pokemon. And this is a lot, right? This is a lot to take in. Like we have a whole system now. We have two different programs talking to each other over the internet. Django does all this stuff. But the more you start thinking about how does the data flow in, right? We get the HTTP request from the browser. Once we get that, how does that data flow through the different parts of our program? And then how does the data flow out? I didn't put the database in here, but this is where we talk to the database. It's going to be a lot, and you're going to want to draw a lot of diagrams. That's how I learned this in school. That's how I learned this on the job. A lot of the senior engineers spent time with me in front of a whiteboard drawing this stuff out as I learned it for the first time. But this is the flow you want to get comfortable with, right? Because this is kind of like our bread and butter. Does seeing this help maybe get a bit more comfortable with how the pieces connect together? Okay, awesome. Now that we've seen it, the diagram, let's write more code. So let's do the same thing for moves. So we have to make the project URL path. Then we have to make the app URL path. And then we have to make our view class. And in our view class, we want to get data from DB, serialize it, send it back in an HTTP response. And normally, because order matters, like if I put this at the bottom, it can kind of make a difference. Let's do this now for moves. So we've got API1/v1/moves with the slash at the end, which is always my gotcha. And we're going to do include moves app.urls. Now, that file doesn't exist yet. And in fact, it's move app. And in fact, this should be move singular. Singular versus plural is also one of the big gotchas. So let's go ahead now and make the URLs PY for the move app. I'm gonna cheat a little bit. I'm gonna open up, and it's not cheating at all. I hate having to remember things, so I'm just gonna copy this import path that I need from the other URLs PY. I'm going to write my URL patterns. And I'm going to make path. And I'm going to give myself a little reminder here of what the full path here is. And that's really all it is. That's really all I need. And at this point, what I need to do now is I need to make this all moves class, right? It doesn't exist. And I just want to check in to see if folks have any questions thus far. Now that we're seeing it again, are we feeling a bit better about the flow?
Yeah, I think that TL draw helped a lot.
Awesome. Let's go ahead and let's build our view class. And again, why late? I don't want to make life hard. For learning, yeah, it's good to type stuff out. But especially as your projects get bigger and bigger, things that are sort of boilerplate, I usually have already written code like on a split screen. And in fact, I just have it as a reference. This is how most of the software engineers I know write code, and I highly recommend it. And now we get the best of both worlds. We can type along for learning purposes, but we can also have our reference code. So from models, let's import our move model. And from our serializers, let's import our move serializer. And now let's make our view. And I can't stand this particular comment.
You selected the model serializer, not the move serializer.
Oh, thank you so much. Thank you, Jack. There we go. So let's make our class all moves. And in fact, let's pull up this one as our reference. Excuse me, not that, but this guy. We're going to inherit the API view class. We need to make a method for each HTTP verb we want this class to be able to handle. So this is a GET request for all moves, right? So this is going to be GET. And we're just going to do moves equal move serializer. And I'm going to pass in, I'm going to use my move model objects order by name. And I have to say many equals true because we're getting a whole bunch of moves back. And then we can return as a response our moves. And just for fun, I'll add a print statement here, just saying, like get move view, and I'll add a print statement here, just printing like the moves.
Is there a difference between response and JSON response?
Yeah, absolutely. Great question. This response object from Django REST framework will automatically convert all this dictionary stuff to JSON, and we don't have to wrap it. And it can probably handle text and everything else. It's just more flexible and powerful. Yeah, so the one from Django was really just for demonstration purposes. Moving forward, you definitely want to use the response class from Django REST framework. Yeah, very good question. So fingers crossed, this works. I did forget something. I didn't do it on purpose, but that's the beauty of having reference code. What did I forget here? And it's hiding on line 13.
Dot data.
Yeah, exactly. With the serializer, I have to access the dictionary that actually has the data. And that's the biggest gotcha with this stuff.
So if we don't want to use JSON response, should you refactor line 36 on that document on views?
Oh, yes, but you guys won't even be writing function-based views from this point forth. You'll always be doing class-based views.
Okay.
Yeah. Oh, and actually, I tried to do that before and ran into something I didn't know, which is I got some sort of error, and the errors, to me, it implied that this Django REST framework response depends on something that APIView is doing. So there's some extra step if we wanted to use it there. So it's just not worth it. But otherwise, yes, that is a good thought. So now that we've written all this code, and let's drop the split, let's go here, and it's not API slash v1 slash Pokemon, it's API slash v1 slash move. And lo and behold, we did great. We got all our moves. We can see all the GET requests. We can see the very nice looking response here. If I want to see sort of the raw response, I can just type in move. And it's unfortunate we don't really get to see the raw JSON response because Django REST framework sends all this stuff back. Though actually it should be, yeah, it's somewhere in there because we're able to access it later. But it's not worth me playing around with it right now. But we've got all of our Pokemon moves. And you can see too how like serializers are a lot of work, but all of a sudden, once you start putting all these pieces together, it's really powerful. How are people feeling? What questions do folks have? And just to go through the flow, the HTTP request flow with the diagram one more time. Let's bring this back. And there's a lot of crazy arrows here, so we'll just kind of delete them and we can redraw them. And let's in fact do this now for a move. And in fact, we might as well throw in the browser. You know, or the client, right? It doesn't have to be a browser. It could be a command line program. It could be a React program running in the browser. It could be anything. And now the HTTP request is get API v1 Pokemon move. And let's get rid of that old response. And the request comes in, right? It goes to URL patterns, but this time it's going to moves. Django checks this first one. It's not a match. It goes to the second one. It is. Takes us over here, which I have to scroll down a bit, but is our move URLs. Django does pattern matching in order. It's not this first one. I totally need to fix this name here because this says a Pokemon and all Pokemon, and this is for moves. And we can write an individual move in maybe just a minute, but now that's as it should be. It goes on to the second pattern, and this does indeed match, right? Because it's just plain old API/v1/move. And my apologies, this actually should also not have the S in it. Again, one of the biggest gotchas for me, that and the slash. Django knows we're using Django REST framework. It's a GET request. It goes over here. In fact, we can kind of add on to this, and let's put Postgres in the diagram, and Postgres can look like this. Though why I want that shape, I don't know. But we've got our Postgres. And in there, we can even throw in our table. Right? And then our model does the job of talking to the database and getting that data back. The serializer does the job of turning it into a dictionary. And then we pass it into Django REST Framework's response class, and we get an HTTP response back. And, it's 200, okay. And all the Django REST Framework debugging fanciness aside, it's a list of, Pokemon moves. And I can't remember the other moves, but I know one had something to do with like thunder. And so this is like the term I use is like the HTTP response request flow. And often you don't worry so much about all the moving parts. You just think about the client and the server and maybe the database. But while we're learning this, I think it's really useful to see it this way. And I honestly would like be drawing this out all the time while writing code as you all start to get used to this more.
When you created the moves, did you go through the project URLs and update that?
Correct.
I don't remember having seen that.
Yeah, I did it right off the bat. Right here on line 42.
Okay, that makes sense. Thank you.
For sure. Yeah, what questions do folks have? What's on people's minds? So we've covered a lot of ground here, right? We've covered GET requests, we've covered getting individual parameters. We've now added in a move. Up next, I do want to show you all how we can start to customize some of this logic. If we go to our URLs PY for our Pokemon, over here, we're searching it by name. Right. And there's the capitalization issue, but that's really more of a data issue, to be totally honest. But it sure would be nice for our API. Maybe we want to search by ID too. And what would be even nicer is if maybe this endpoint could accept a Pokemon name or an ID. Right. And so that's what we're going to build next. And I'm going to make one brief change here. Since I changed the name, let me open up URLs PY for our Pokemon app and close some of these other things. I changed the name here, and that's a variable name. I don't think I have to change this name here, but for your sanity, you absolutely want to. So this is going to be an ID, and we'll just make a comment to ourselves like ID can be, integer or string, Pokemon ID or name. And let me just change this here and here. And this should still work just fine for a string, but it certainly isn't going to work for an integer. And so that's what we're going to do in just a minute. And I'm just going to make sure I haven't broken anything, right? Let's test this out with Charmander. We still get Charmander. But if I put in, ID 2, we get it does not exist. And we get an error. Right? Because our query tried to find Charmander, tried to find a Pokemon with the name of 2. And that most definitely does not exist. So that's what we're going to do next, is see how to build sort of a custom validator for this. And we can see here in our Django server printout, we see the same error message.
Right now, in our custom, both the moves and the Pokemon for the A Pokemon, you have name equals A Pokemon, and then when you pull that up, it says A Pokemon instead of the name. Can you pass that a variable instead?
Oh.
Like,
Which line? I'm sorry.
it's in. So if you go back to your server and pull up one of the Pokemon you have or one of the move names you have, Pikachu, for example, in your server.
Oh, you mean like over here in the
Yeah,
admin?
over there. Instead of 2, just do Pikachu because
Oh, got it, got it, got it.
you have Pikachu, right?
Yep.
And it says right there on the top, it says a Pokemon instead of the name.
Oh,
And that's
right.
because in your URL pattern, after you have a Pokemon as view, name equals a Pokemon, I would imagine. Or how would you change that to a variable to actually state the name of the thing you're pulling up?
Oh, this right here.
Yeah.
Got it. Yeah, you don't actually want to change that. This, what this is it's called a related name.
hmm
When we write tests, we're going to use this name so that we can basically send data to this endpoint without having to like write a whole URL in a GET request.
Okay. So
So
it's just a generic identifier that you can use for multiple purposes.
yeah, like I could name this whatever I want, like one single Pokemon. I actually did not even realize that Django REST framework showed that there, because I just never look at it.
Yeah, I
I
didn't
would
do
have
either.
thought that this,
Maybe it's pulling from you have a Pokemon as view because that's the title of your view.
yes, yeah, no, you're correct. That's
But there's
exactly
no
what it is.
but there's no underscore there.
It's trying to be nice for us and probably getting rid of the underscore. This is probably the name of the view function. I'm honestly not sure what this is.
Okay.
Um, that
It's
is,
not a huge deal. I was just curious.
yeah, yeah, interesting. I think it is the class-based view name because we'll eventually add more methods here. Like, and let's change this to like my Pokemon, and if we change that here, interesting. Yeah.
'Cause,
Um,
yeah, even if you do
yeah, it's sort of a
okay.
hierarchy thing. Like, out of all the Pokemon, we can get one
Yeah.
individual Pokemon. So I think that's what you're seeing. But it looks like it's showing us the class-based view names.
Okay, no worries then.
Yeah. No, that was cool. I actually didn't know about that at all. So it's good to see. Yeah, I would pay, this is kind of the main thing to pay attention to right here. Let's see, and is everything there still working? Yeah, we're good to go. All right, let's talk about this query parameter and making a custom converter for it so we can take both a string and an ID. because I want to be able to do this, right? Pass name string, but I also want to be able to do pass ID int. So to do this, we have to write what's called a custom converter, and we're going to make a file named converters. And in it, we're going to write a class. And I'm going to call this int or string converter. And it's going to be pretty general. I do have to add an attribute to this class named regex, because Django is going to look for this. So Django needs this. And our regex is going to say that if our thing has a number, one or more numbers, or, and that's what the vertical bar does, we have a lowercase or uppercase letter, and we can have one or more, then we're valid. So this regex allows for numbers or all letters, right? I can't have a mix of numbers and letters, but I can have all of one or the other. I then do have to write these methods with these specific names, because this is just how Django needs its converters to be. Where we pass in the value we're going to test here.
Is that to Python or to Python?
Thank you. That is totally a typo. That is 1000% to Python.
And what about on line 4? You have A through lowercase z.
That is correct, because I don't want to have to worry about if in the URL there's a lowercase or uppercase letter. Both of these should be permitted.
Yeah, but you have lowercase a through z and then uppercase a through lowercase
Oh.
z.
Thank you. Yeah, you're absolutely right. I did not see that. Thank you, Tim.
No problem.
So we're checking for a digit. And if it is, we have to cast it to an integer. And this is actually important. Everything that comes in a URL is a string, right? If we have some JSON in the body of an HTTP request, there's actually integers in there. But in a URL, it's all strings, even if there's a number in there. So we have to do some casting. If it's not a digit, I know it's got to be like letters. So we'll leave it as a string. We don't really need to cast it, I don't think, but it can't hurt. And we'll return it like so. And later on for testing, we need a way to go in the other direction and turn this into a URL. And because a URL can only have strings, we need to cast this to a string. And my apologies, this needs to be a method. So this is, we're going to use when validating a URL query param. And this is when generating a URL, which will become more relevant with testing and later on. And this is just the way that we have to write this converter. If we look in the Django docs, we could find, a definition of it, but it needs a property named regex. It needs a method to Python, and it needs a method named to URL. And in fact, let's put our converter over here for the time being. And let's put our view. In fact, we don't even, well, we'll come back to the view later. So now that we have the converter, we have to import it and use it. So we can import it like so. And then this is where Django does get a little magical. we need to register our custom converters. So I have to use a method register converter, which I actually need to import. And as you can see, it's expecting a class definition for a converter. And we're going to be able to give it a name that we're going to use now in URLs PY. And now over here, I can use my converter, right? And we call this magic. This is sort of a magic string, right? It's text, but it has to be in this special format. You kind of want to avoid this as much as you can, but in this case, it probably makes sense because it's relatively straightforward. So now this should give us an integer or a string that will get converted. But we have to do some extra work because if we look over here in our views class, this ID will sometimes be an integer and sometimes be a string. So for instance, calling id.title on integer will break. Calling it on, I'm pretty sure, calling it on a string will not. We can kind of play around and watch this in action. I'm not sure if I need to restart my server after registering a converter, but I'm going to just to be safe. Let's see what happens if this works with Pikachu. So this still works with Pikachu. Let's see what happens if we pass in 1 though. So here we get an error. And indeed the error is int object has no attribution title. We see here, somewhere on here, it's got to have the line number that this error is thrown on. And in fact, it's here, exception location. So it's a little digging, but this is one of the most important bits of reading these error messages where I can see the file and the line number. And indeed, that error is right here on line 14. So I need to check if I've got an integer or a string. Let me give myself a little room to work. If the type of RID is an integer, then let's get a Pokemon like this. Let's take this print statement and put it here, and we'll just refactor it to be simpler. And if, let's see, I have curly brackets that need to go. And I had I think a period in there. And now I think that should be a valid F string. And if I don't have an integer, I know that my converter has guaranteed it will be a string. So I can just do this. And we'll do our title casting again. We can get rid of this line of code and the rest of our code should work just fine. And now let's run this and see how we do. And now we're able to get Pikachu using an ID, using a name, and it doesn't matter if it's uppercase or lowercase. I think everything in the URL gets lowercase anyway when it's sent in the HTTP request. And we have our custom converter. Let me actually take a quick look at our Zulu questions channel to see if there was anything I missed. I apologize, I wasn't tracking that earlier. But yeah, what questions do folks have and what's on people's minds? How are we feeling?
What's the point of using a converter and go through the hassle of making a class,
Yeah.
go making a file, when I can just do the logic inside a Pokemon class to see if it's a integer or a string and then continue from there?
Yeah, good question. It is an extra hassle. The benefit is, while I can put that logic in here, the problem we run into is before we get there here with our URL patterns. Because if I don't use a custom converter, I have to specify like what type this value gets converted to. So, I could just convert everything to a string, and then I might end up, with like ID equals 1 or 13. And I guess I could write some Python code that tries to figure that out. I could probably use the exact same regex that I did before, but it's a good design principle for OOP for separation of concerns. It really shouldn't be this method's job to deal with this. We want that to be handled before we get here. And this way, we might have other routes, like say for a Pokemon move, where we want to do the same thing, and now I can reuse the same converter. Does that help answer your question?
Yeah. So when you are trying to pass in a variable through the paths, it's not like React where you don't have to specify if it's a string or integer, but in Python you do.
Well, yes, right here with this path function, that's exactly it. We have to specify, and it's gonna turn it into one or the other. And then also I think the reuse is a big one, because if I go to URLs py for move, if we want to do the same thing, we haven't written the a move class yet, but you guys can kind of imagine what that would be like. It's really nice that I only have my regex in one spot, but now I can use it in multiple places. You won't always do this. Truth be told, it's kind of nice to have this either be an ID or a name. But you could imagine how if you're writing code and you're using this API, it's actually kind of useful to be able to go back and forth. Why don't we take a short break and then we'll look at testing. How does that sound to folks? Okay, cool. Oh, I did find a better way. Instead of doing name title here, we can do something a little different. I got a little help from Claude AI, actually. If we do a filter, we can do something like this. And then I think we pass in the ID, but this is going to return a list. Like let's print query result, and let's print Pokemon. And let me go ahead and kind of clear the database here. And we can hit our endpoint using Pikachu and see what it says. So we get a bunch of errors, right? Which I'll show in a sec. But if we go up, Pokemon ID Pikachu, I would have thought we hit our query result sooner. Cannot resolve keyword name iExact into field. Yeah, I may be doing. Oh, I think I need 2 underscores, which is I have not done a ton with this filtering kind of approach. There we go. And while I get what they're doing because it's really powerful, Like it's kind of a clunky way to do it. But now we see here a query result, which is printed out twice, because I also have print Pokemon here. So that's okay. But this filter returns a list. So we have to do a little bit of extra work. We know there's only going to be one thing, because we know the name is unique, but Django doesn't know that. And yeah, I may have to debug this one a bit more offline because I thought this would get us there, but there's a little more work to do. So let's take a 5-minute break. We'll look at testing, and I'll make sure when this code gets pushed up after the lecture that it has that correctly implemented. Sound good? All right. Thank you, everyone. And I'll see you all in 5 minutes. All right. We've spent a lot of time with API views. Now we're going to switch gears. We're going to talk about testing, and we're going to do a couple things. We already have some tests from before that test the Pokemon. But we have a move app now. It might be nice to put all our tests in one spot. We're also going to write tests for our API views. So just to kind of like warm us up on tests, I'm in the project root directory, and I'm going to run our tests, make sure everything is working. We have our print statements, everything is good. We have test 8. Someone maybe want to quickly walk me through what this first test is doing on lines 8 through 17.
I mean, the create poke is validating the data, the new poke.full clean,
So what's the purpose of this test?
essentially to make sure it's created, and passes a validation test, essentially.
Yeah,
And if it doesn't
exactly.
pass them, then raise a validation error.
Yeah. And really, we're testing that we can create a Pokemon, where we know everything is good. Because we know that this stuff will pass validation because we put it in the test. So this is sort of a sanity check test, right? Just to make sure that making a Pokemon works. And you're totally right, Jason, that the validation runs, but this test is really where we're testing our validation logic is correct, right? Like here, we just want to make sure that creating a Pokemon with good data works. Now we want to make sure that our validators throw an error when it should with bad data. So we deliberately feed it bad data. As I said, I really hate putting uppercase letters into a database when we don't need them. But we know this is bad data because our Pokemon name has to start with an uppercase letter. We run our validation. We've designed the test for it to fail. So if this validation doesn't throw an error that kicks us into the exception, something has gone wrong and we want the test to fail. But the validation is working. It does throw an error. It kicks us into the accept block. We print out that message, and that's what we see in one of these print statements here. And then we do an assertion to check that the type of error is what we expect it to be, that it's improper name format. We're doing it again here. I'm not sure why we're doing the same thing a second time. Oh, I'm so sorry. We're doing it a second time because we're now testing the other part of the name, that you can't have a letter in there. So once again, we do the same thing. We expect the validation error to be thrown, and we check that we get an improper name format message. So this is what we've put together, over the past 2 days. And we have it living inside our Pokemon app in this tests.py file. But we're going to restructure a bit where we put our tests. Right now, I'm in the top level of my project. And that's actually where I'm now going to make a new directory named tests. And I'm actually going to move this file into there. And I'm just going to, I could test all my models in here. I think for simplicity for the refactoring, I'm going to have it be a separate file. So what I'm going to do is I'm going to do move Pokemon app tests py into tests, and we'll call it test model Pokemon.py. And this is going to be my convention. I say what I'm testing and then like which model or which API view. And so now that file's gone, but it's shown up here. I do have to make some changes, right? This was a relative path, but now this needs to be a full path. I need to give it the app, and that's our top level Django model namespace. And inside that models is the other Python module, and that's where we're importing the Pokemon class from. And now, fingers crossed, I can still run the tests. We have to do it a little differently. I'm using the test command, but I am giving it the path to where the test files live. And it Django loves to create dunder PyCache directories. I don't know why. It's for caching to sort of improve performance. You can delete them to your heart's content. You should, in fact, use git ignore to ignore them. They don't matter. You don't want to touch them. Try to use a git ignore to not put them into version control. And I'll show people how to do that later.
I got a quick question real quick.
Yeah, absolutely.
So the test is a tests folder like in the project directory with manage.py.
It is. This is where I want to be
Okay.
careful because the names are so confusing. It's
Yeah.
in our root project directory.
Okay.
With manage py. If this wasn't, in demos and notes, this is where probably the README would be. But this Pokédex project directory is this other one. So this is the root directory of our whole project.
Okay. When you run Python manage.py test, doesn't that like just run all the test files like throughout the directory?
Let's see what happens. I'm actually not sure.
Okay, I guess not.
Well, it probably did, but it probably looked inside the apps, and there are no tests inside the apps. We don't have any move tests, and I moved the ones in the Pokemon app. So I think if there's not a file named tests inside an app, we have to pass. This is almost definitely like a path.
Okay.
So we have to pass the directory name. Like if I named that directory my tests, this would be my tests.
Okay.
Yeah. Does that make sense?
Yeah.
Since manage.py is already looking in all of the app folders for test folders called test.py, what's the point of moving it to a root directory test folder?
So yeah, that's a fair question. To be totally honest, I'm not really certain like what the best structure for tests are. It's quite possible we might end up with tests in all places. Like we might have some tests specific to the Move app, some tests specific to the Pokemon app. But as stuff gets more complex, you need tests that cut across both.
Well, I mean, having a test folder like allows you to see it all in one place as opposed to like zipping between a bunch of folders.
Yeah. And there's more than one right way to organize it. I'm not sure there's a solid answer to that, Tim, but I will say like as we get more and more apps here, we will have more and more tests that are testing our interaction between them. And I'll try to follow up with like a best practice answer to that. But
Sorry, go ahead.
No. That's all I was going to say.
I'll just say one of the things I dislike about Django is that in all of the app in all of the app folders, the file names are all the same. But that also lends itself to consistency,
right?
and this seems like it's breaking that consistency.
Yeah, let me follow up later with like what the best practice pattern on this is.
Yeah, so it's like you gotta delete all the test.py files in all the apps, and then you have to, I guess create urls.py in all the apps as well. I
You
mean,
don't have
compared
to
to how it
delete
starts off.
anything. So that's fine. You can just leave them. That's fine. It doesn't matter. URLs py you do have to create. Yes. Yeah. So you will be creating in each app a URLs py file. Validators, honestly, this should probably live in the project directory if it's well, oh no, not validators, excuse me. Converters, right? If we actually want to share this between apps, it probably belongs in the project directory, but that's something we can show later. I do want to make sure I cover writing tests for APIViews, so I am going to move on, but I will follow up with sort of some best practice on like test structure organization. So we've seen writing tests for models, right? We have Pokemon tests. We can write some tests for moves if there's time. I will get there, but I want to make sure that I show testing some views. In fact, just for our own sanity right now, I am going to just rename this to test models. And maybe what we'll do later is it will add the move tests in there. And I am going to write now a file named testviews.py. And we're going to have to do some of our default imports. Import test case. We're going to have to import something called client. And this one is good to look at the pop-up description here. Someone want to read this for me just so it's not my voice all the time? Just like maybe the first two paragraphs.
A class that can act as a client for testing purposes. It allows the user to compose GET and POST requests and obtain the response that the server gave to those requests. Server response objects are annotated with the details of the context and templates that were rendering during the process of serving the request.
Yeah.
Client objects are stateful. They will retain cookie and sessions details for the lifetime of the client instance.
Awesome. Thank you, Jack. I appreciate it. And some of this we don't have to worry about. We will learn about cookies and session stuff for authentication later. Contexts and templates we don't really use, and templates are in fact outdated. But this part here is really the key bit, right? We're going to be able to send, get, and post requests and thus test our API views. We also need to import from Django URLs a method called reverse. And this is going to use that name that we were adding to all our URL patterns. So we don't have to constantly like actually type out a full HTTP like URL path in text. And we can also get some Django niceness with it. We're going to need to deal with some JSON. And we're also going to need to come up with some answers to the tests so that we know what correct data looks like, but we will cross that bridge in a bit as I just want to get some tests rolling. So I'll just make a note here to do, create an answers PY file with correct API response data for our tests. So we're going to write a test views class, and we're going to just start with our Pokemon. We actually do need to use fixtures for this test, and the test case class will do this for us. I can give it a class attribute named fixtures, and here I can pass it the file names of the fixtures that I wanted to load into the test database. And this is also where our fixtures become useful. And I just wanted to make sure I had that name right. So before our tests run, these fixtures will be run and loaded into Django actually creates a new database whenever you run a series of tests. And we can also use what's called a setup method that will run again before our tests to set up things we will need in all of our tests. And we're going to need to make HTTP requests all the time. So we're going to make an instance of this client.
Is your
And that
trailing comma on moves going to hurt you later?
It shouldn't with Python lists, but it certainly won't hurt to get rid of it. Yeah, it's a good idea. Thank you, Tim. And now let's go ahead and let's write our first test, and we're going to test getting all of our Pokemon. I'm like 99% sure trailing commas are fine with Python lists, but better safe than sorry. So here's where we use the client to basically like create and send an HTTP request to our Django server. And the test, I believe, will do the work of, sending the request to Django. And we can, in fact, get a response from Django. And this is where I need to use reverse and this name. And let me pull up our URLs py. And by the way, Control P or Command P is what opens up this file searcher. And I do recommend getting comfortable with it. It is quite useful. Then you can use arrows. You can actually use Control N and P to move up and down. And so over here on line 12, where we had this name, we now get to use this so that we can send our HTTP request directly to that view, right? Which makes the testing process really easy. Now we want to look at the JSON that got sent back, because that's what we're going to have to see. Did Django send back the correct data for this request? And I'm going to use the Python standard JSON library. And we're going to load response.content. I believe this will take the actual JSON and turn it into a dictionary or vice versa. Let's in fact just do a little double checking of things as we write this test. And I think I'll just add like self assert equals true and true. I just want to see what this print statement looks like in the test to make sure I know what my data is like before I start writing the assertion. So line 22 here is just sort of a nice workflow trick when building tests. And I'm just going to run all of these. And we see it's a list. So this does indeed, like I was thinking, our response content is the actual JSON text. And this loads that JSON and turns it into dictionaries and lists, which is exactly what we want, because now we can do some nice comparisons. And I am totally going to do a little bit of cheating here, though in fact, this is actually not cheating at all. We are going to copy this, and we are going to make an answers py file. And I think we're just going to put it in this tests directory. And let's do a little formatting. And we will call this maybe like all poke response or something like that. I think we can just call it, for simplicity, we can use the same name, all Pokemon. I'm going to give this a sanity check to make sure it looks good. This looks like a Python dictionary the way it should, so I think we're good. And I think I'll put this to the other side of my split for my workflow. And now I should be able to from dot answers, import all Pokemon, since with the Python module and every file is a module, any kind of variable at the top level we can import. And now I can do assert equal, and we should be able to compare our response body to the answer. So response body should equal the answer. Or should equal all Pokemon. And in fact, you know, if I want to, yeah, I think this is fine to leave this here. We could maybe namespace this or do like all Pokemon as like all Pokemon answer if I wanted to worry about keeping track of names, but we don't have to worry about that right now. Now obviously, if this stuff that I copied here is wrong, then we have a problem. But often, like, you know, when you start out simple, this is a nice way to do it. We could also have grabbed this from the browser. There's a number of ways to grab this, but we can have confidence that this data is good. So right now this test is simple, right? But as we maybe add more code to our API views and stuff, that's when this test has value and we can add to this as time goes on. So fingers crossed, we run the tests and it looks like I managed to do something foolish in my import statement with answer. So let's see how to fix that one. That is probably just my brain being ready for lunch. I think this cannot be a relative import. And in fact, if we look at the error message, attempted relative import with no known parent package, that is a pretty good confirmation. So this should be tests.answers. And I believe this is because of the behavior of the test runner that's running this code. So that's a little out of scope. And now our test runs, everything is passing. I'm going to, I'll leave those, but I'll comment them out. And now we've got a test. I realize we ran a little past lunch, so this might be a good stopping point. I think, let me just show how to test getting an individual Pokemon, and then we can call it. Sound good? Okay, awesome. And an individual Pokemon is going to be very similar to this. And in fact, I'm going to copy this whole test because about 50% of this I can reuse. But I'm going to change this to a Pokemon because that's what we have here in URLs PY for this other route. And now if we run this, we're going to see a couple errors in the test. If we scroll up a bit, the first error should be, here we go. No reverse match, reverse for a Pokemon with no arguments not found, right? One pattern tried. The problem is that this pattern requires an argument that we did not pass here in the reverse. Luckily, because obviously this is something that's really important to be able to do, the reverse method has a way for us to do that. And we use this named argument args, and it's a list. And inside it, we can put whatever we want. So in this case, let's just put our Pokemon's name for simplicity. And I need an equal sign there. And now I can run my code. This will still fail, right? I haven't gotten my correct data yet. And it looks like there's another error. Reverse the name, Pikachu. Reverse for Pokemon. I think
Is your line 31 a problem? You're still calling all Pokemon in the response body.
No, because this is the answer data. So this, I know this one's gonna fail.
Okay.
We need to create our correct data. I think I need to add the name of the arg here. But I'm honestly not sure. But what we can do is let's comment that out. Let's just do self assert equal true, which will pass. I'm about 99% sure we're going to see the same error though, based on this message. API/v1/Pokemon. We have a Pokemon over here. We have enter string ID. If I'm kind of looking at my notes, I think we should be good to go. But there's something simple that I'm missing here. Let's see if let's do a quick Django reverse. Let's take a quick look at these docs, and then if we can't sort it out, we'll kind of keep on moving. So it seems like we're using args the right way. We see them doing it here. We see reverse. They're doing some extra stuff here. In the interest of time, I'm actually just going to use ChatGPT because I do want us to have a correct implementation for this.
Are you closing your reverse after a Pokemon? You closed that parenthesis, but that didn't have that on the docs.
Yeah, you're 1000% correct. Thank you. And we need a second closing parentheses. Yeah, thank you. Yeah, Tim, good eye. So actually, there's two really important lessons from this. The first is if I'm going to do a mini retro on how I caused this programmer error, it's because I copied and pasted some of this code, right? If I hadn't copied and pasted, I probably wouldn't have made that error. The second thing is this is the best kind of mistake to have because the solution is easy. Also, ChatGPT probably would have caught that. So again, I think ChatGPT, like, if you've been debugging for like 30 minutes and you're losing your mind, ChatGPT is a good tool to have in the toolbox. And now our code's running. Now we're off to the races. Now I've got my nice fake data that I want for Pikachu, and I can put this in here for a Pokemon. And because this depends on the different Pokemon, I'm going to call this a Pokemon Pikachu and just paste it in and format it. And now let's go ahead and import our correct answer for our second test. And now we can make this a real test and say response body. Let's make sure it's failing when it should. Let's test it with some false data first. That's always a good idea when writing tests. It indeed fails. It's exactly what we want to see. It's telling me that the data doesn't match. Now we test our test with correct data and we're passing. All right, folks, thank you. I realize I ran a bit long, so thank you for sticking around. Let me go ahead and stop the recording.